That's pretty much where my Latvian language ends. My name is Ben. I came this morning from Lisbon. Normally, I'm based in Amsterdam. I'm CEO and founder of a company called Plumery. We are building digital engagement platform for banks and banking companies, Fintech, digital wallets, and similar type of organizations. We'll talk about Plumery a little bit later, but today our topic is unlocking enterprise agility. So I'll try to elevate a little bit the microservices topic to the level of enterprise architecture and how does it fit when we want to compose different bigger applications together to fulfill certain needs of a business. So let's kind of recap a little bit what Justas already told and look into what microservices are. Maybe a little bit more from fundamental principles, right? We already discussed a bit what benefits we're trying to achieve, but how we do that. What principles do we need to apply to achieve that? So generally, when we talk about microservices, or in a broader sense about decoupled systems, we have four things in mind. They have to be independent, they have to be loosely coupled, they have to communicate with each other using some sort of API driven communication, and they should enable polyglot programming. So let's try and unpack each of it a little bit separately. So independent services. Well, this is pretty easy to understand, right? It's all about taking functionality of a system and decomposing it into individual services that can run independently. That's very basic principle. When we just take it from a first glance. Then comes loose coupling, right? And what loose coupling means and how is it different to independent services? Because it seems very similar, right? So independent services, loose coupling, this seems like a same terminology, but not really. Making services independent, it's easy. You just take a functionality and you split it into different small services. But are they loosely coupled, right? Can they actually exist independently? Can you turn down one service and still have the other service running? This is one of the fundamental and important principles when building microservices based architectures. And this is where it fails a lot of times. People often just take one part but completely forgot the other one. And with that, they create what Justas already mentioned, a distributed monolith, right? So taking things that are very coupled together, depend on each other a lot, and just deploy them independently. By that, they create even more complexity and make life even harder. So one of the important things to consider when designing microservices architecture is to make sure your services are loosely coupled. They do not depend on each other. And that's also related a little bit to API-driven communication. Most of the microservices architectures I've seen are using RESTful APIs to communicate between services, right? Typical APIs that are most common today. But that's not the only way how microservices should communicate. RESTful APIs are great. They are very easy to understand. They are relatively easy and simple to build. But they are also let's say complex in nature because they create high coupling, right? One service calls another service and waits for response. It's a synchronous communication. It's communication where if you don't get response from one service, your service that calls that other service cannot exist, right? Cannot work. So I always encourage when we design microservices, both in my current startup and prior to that, I was a CTO and CPO at a company called Mambu, which is a globally leading cloud banking platform. When my team designs microservices, we always encourage asynchronous communication, which can be event-driven, message-oriented. Doesn't matter too much. What matters is that as a service, I request certain action from another service, but I don't wait for that action to be fulfilled to continue my own process, to continue my own journey. It's much harder to implement, but as a result, it makes architecture simpler. And I'll get back to that. It's an interesting differentiation. easy versus simple, which is not equally understood sometimes. And last but not least, polyglot programming. And it's not just about programming, as Justus mentioned before. It can be about databases, it can be about infrastructure. So it's about polyglot architecture in a broader sense. Microservices enable us to apply different architecture mechanisms, technologies for individual services or individual set of services. You don't have to do that if you don't need, right? But important is that this architecture style enables us to do that. We have optionality. If we decide that in one area we want to use one type of database, we should be able to do that. With monolithic architectures, still possible to achieve, but much harder to do so. So yeah, so these are kind of fundamental principles that are driving microservices architectures. Now, let me get back a little bit to simple versus easy. How many of you know the difference? Can you raise your hand? Do you know the difference between simple and easy? Okay, let's see. Let's see whether you understand the same way as I do. So Marius today mentioned during the introduction that monoliths are simple. Well, I want to challenge that, right? Are they simple or they are easy? Because one of these is true. Monoliths are definitely easy. It's very easy to create something that is close to our understanding, fits well into our mind. Oh, it's just one thing, right? We put everything there. It's easy, but is it simple? I don't think so, because simplicity means one task, one role, right? Something that does only one thing and it does it well. And that's the fundamental difference. Monolith is one thing, but it does everything. Microservice is one thing, but it has one role and one task. And when you do things in a simple way versus easy, you suddenly have a possibility to maintain that one thing much easier without impacting the rest, right? You can evolve that one thing independently. You can fix issues and bugs in that one thing without impacting the rest of the architecture. So I don't have a slide on that, but what Mario said in the morning triggered my thinking that, yeah, we have to actually unpack a little bit the difference between simple and easy. That can be a whole different talk altogether. And I think this is also a very important concept to understand when thinking about moving from monolith to microservices, or even for that sake, another provoking idea, moving from a monolith where everything is interdependent and intertwined into a monolith where things are modular and decoupled, which is also possible. Okay, another question, is microservices an architecture or an architecture style, right? And what are the differences between these two, and how is it important at all for our conversation today? Let's define what's architecture. In a general sense, architecture is a high-level design that describes different elements or components of a system and how all of them interact together, right? It kind of organizes the overall structure of the system. And when we talk about architecture, we don't necessarily have to care about whether it's microservices or monolith, whether it uses Java or .NET or whatever other technology. It's actually important to first understand what that system is supposed to do, why we are building that system, and how it's organized on a functional level, right? What the responsibilities of that system, how we need to structure it, and how different pieces interact together. And how monolith architectures are going to a wrong direction is by not having an architecture, but just thinking about it as a technological exercise. Or let's just build something, right? This is also very important. Microservices are inherently more complex, but they are also more simple if you do it right. And that's an interesting differentiation back to what we just discussed before. And what is architecture style? Architecture style is already a particular set of principles and practices that you apply to build either the whole system together or individual parts of the system. And when you separate these two concepts, I mean the architecture and architecture style, you suddenly have flexibility to decide whether you want to apply a particular architecture style across the entire system or just across particular domains or basically parts of that system. This is especially important when you are transforming existing monolithic architectures into microservices. You cannot do it, typically you cannot do it successfully all at once. And that's where it's important to understand, okay, how my target architecture should look like purely from structure perspective, what components, domains it will be comprised of, how these domains will interact to achieve specific meaningful business outcomes, and only then apply one or the other architecture style across particular areas of that architecture based on your specific needs. Let's say you know that certain parts of your system require high level of maintenance, you change it more often, or requires different level of scalability or elasticity, the characteristic Justas was talking about, where let's say during Christmas period, certain areas require more scale, and then you need to downscale it, right? So you then would apply microservices architecture style into that particular area of your system first, and then gradually transform the rest of the architecture if that's needed at all, right? So it's a very important differentiation here. Is microservices architecture new at all? Right? Have we seen that before with any other technologies or architecture language, programming languages? And I'm obviously specifically provoking here with Oracle PL SQL. It's not because I advocate to build microservices using Oracle PL SQL, but just want to mention that this approach itself is not new. We did gain some advancements in terms of how different programming languages support microservices ideas today. A lot had happened since the introduction of service-oriented architecture with SOAP-based web services and things like that. We have things like Kafka that is much simpler to use comparing to WebSphere Message Broker and things like that. But at the end of the day, the approach itself is not new. You can easily build microservices architecture using Oracle PL SQL. Oracle PL SQL shares exactly same characteristics. You build independent packages that can be maintained independently, deployed independently. These procedures within Oracle PL SQL packages can interact with other PL SQL packages using internal queue mechanism or database tables, so on and so forth, right? You can even today expose Oracle PL SQL as an API, RESTful API, straight out of the database. So just looking purely from a principles perspective, you can do microservices with PL SQL. Whether you should do that, yes or no, that's a different question, of course. Right? The reason why I mentioned that is just to provoke a bit of thinking, should we start with technology or should we really start with understanding what's our architecture, why we're building it in a certain way, what benefits we are trying to achieve with that, and only then, pretty much as a last step, try to think, okay, what technology am I going to use, right? Am I going to use that framework or this framework? Is it going to be built with Java or something else? Because on the grand scale, from a business objectives perspective, this matters less. What matters much more is how exactly you're going to decouple your architecture and where you want to put your effort to potentially introduce more complexity but gain simplicity versus making things maybe easier but not necessarily simple. So that's that part. Now, how does that fit into the overall enterprise architecture, right? Because when we talk about microservices, we mostly talk about architecture of individual systems, right? We take CRM system or core banking or any other system, and we talk about that system in the context of microservices. Should it build as a monolith or microservices? But how about the overall landscape of the enterprise, where sometimes hundreds of systems exist, right? In my previous life, I used to work for one of the top banks in Baltic states, Scandinavian one, not that one, the other one, and we had around 2,000 systems there. right, that were intertwined and connected. And we used service-oriented architecture for that. It's a grandfather of microservices. And of course, we didn't know that microservices didn't exist at that point, right? But we thought about all these systems as one big architecture that is interrelated and interact with each other. Today, there's a concept for that. It's called composable business, right? Or in Mambu, we used to call it composable banking. We were actually one of the first companies who started to use that terminology in the market. And then later, Gartner picked it up and it kind of became a thing by itself. But generally, what is composable businesses or composable enterprises? And what's packaged business capabilities within that? It's essentially a big microservice, right? You can call it a macro service. It's an application that fulfills, let's say, a bigger need, right? It's a domain, it's a capability like CRM, like core banking, or maybe core banking can be decoupled further into lending and deposits and ledger, right? It depends already how granular you wanna do that, and then you have other potential options there: buy versus build or buy plus build, right? You potentially can buy things that are a little bit more commoditized, like potentially you don't want to think how you're going to calculate interest rates for your loans, right? And you want to go and buy this as a service and use it via APIs. And at that point, you don't quite care what's inside, right? Whether it's built out of 5 microservices or 2 microservices or 10 microservices, as long as you have an API that you can easily consume, preferably in asynchronous way by all other applications, right? So it's kind of about moving your the same ideas or the same benefits of microservices, but to the level of enterprise applications. Gartner called this packaged business capability. I mean, I'm not particularly fan of this term, but it makes some sense. It's about treating certain capability as a packaged thing where all you care about is an API that it communicates with, right? So all of the modern systems well, most of the modern systems, let's say, are built with that idea in mind. They are built with APIs in mind. SaaS is basically fundamentally following that approach where all the things SaaS are provided as in the form of APIs, and you can buy today HR management system and talent acquisition system as a set of APIs, combine that with your ERP system, combine it with your core banking system, and create an architecture where you leverage best-in-class service for each area versus buying something mediocre from one provider and basically maybe having one functionality that is good, but the rest is just mediocre. It just gives you something, but it's not the best, right? So that approach with composable businesses really allows you to easily switch different parts of your enterprise architecture, easily switch, let's say, CRM system, or easily switch KYC system without potentially breaking everything, right? Or without the need to replace the entire architecture at once if you just want to improve how you do your KYC or you do your AML or any other parts of the architecture. So that's just the same, as I said, same approach that we follow on the architecture of individual application, but then apply it to the architecture of the entire organization. Then how much decoupling is enough, right? Why I'm talking about decoupling? Because obviously all the other things we discussed so far were about decoupling, right? Decoupling monolith into microservices, decoupling big enterprise applications into individual business capabilities. What else can we decouple? Well, there's this concept called MACH architecture, where they suggest to decouple further your presentation tier from the rest of the architecture, right? The things that are used for your users or your customers to engage with your service, provided you are providing some sort of digital service. I'm talking about it just for the transparency as an intro to what we offer as a company, right? Not to confuse you. You don't necessarily have to apply MAC for everything, but I want to explain how Mac can be leveraged specifically in digital banking space, right? And why we, as Plumery, decided to follow that approach to build our digital engagement platform. So who are we and what we do, right? As I mentioned before, we provide a new generation digital banking platform that sits on top of core banking infrastructure, such as core banking system itself, AML, KYC, and all other systems, card management system, and focusing specifically on powering up digital channels, mobile applications, web applications that end users are using. And we do that by combining buy plus build approaches, right? We are saying you should be buying things that are non-differentiating, things that are more or less the same across the globe, across different organizations, and you do that to establish feature parity with what's expected by the market today. But at the same time, you should be able to build what's unique and differentiating for you. And we say, buy for parity, build for competitive edge. So that's what we do. We are providing a platform that enables that, gives certain capabilities out of the box as a set of APIs, of course, built with microservices behind the scene, but that's less relevant. What's relevant is that they are completely independent, can be used independently, but we also give the entire DevSecOps environment, which is optional, but helpful to create your own capabilities in a bespoke way. How this is related to Mac that I mentioned just before, we believe that the user interface itself, the mobile application, the web application, is something that is relatively easy to build today. It doesn't require a lot of effort, it doesn't cost a lot of money, but at the same time, that's the part where most of the organizations want to differentiate themselves. This is where everyone wants to look different, not just have different colors and different logos, but essentially build user journeys in some sort of unique and differentiating way. So we leave our customers with the ability to do it in a completely flexible and free way without locking them into specific design ideas that we had. But we take away the complexity, the underlying complexity of that digital brain, as we call it, all the functionalities that you need to power up your mobile and web applications. From enabling transaction cleansing and categorization and searching across your transactions in a Google-like search, to facilitating notifications, push SMS, email, to providing message center to communicate between a bank in a broader sense, employee and the user. By bank, I mean any company, digital wallet, crypto wallet, whatever functionality or whatever type of organization you may be. Managing cards, requesting new cards, managing digital onboarding. We do that with cooperation with some of our partners like SumSup and Forceline and a few other ones. Multi-factor authentication that has a pluggable mechanism to add additional methods that potentially we don't have implemented but are specific in one or the other country. Like we don't have bank ID in Sweden, but it's easy to add that new method into our platform. So that's basically what we do. We try to simplify. On one hand, we try to simplify and accelerate the journey to build digital channels. On the other hand, we give all the necessary flexibility to differentiate yourself where it matters most, from the UI itself to building additional functionality in the backend using our microservices templates, our microservices architecture principles, event-driven, asynchronous, all the things we thought about, all the experience of building such platforms for the last 20 plus years. We try to put it into our architecture. Yeah, I'll probably skip a few things because I already mentioned them. This is essentially what I meant before. Typically, what's expected when our customers are just trying to build a new mobile application. They feel like they can just build a mobile app, a web app, and integrated that with core and done job. In reality, this is not the case. In reality, there is a whole thing here that needs to be implemented really to facilitate these digital journeys on the top. And that's exactly our focus, right? We give some acceleration here as well. We give template web application, template mobile application with all the source code. that our customers can change, but our focus really is here, providing functionality that simply doesn't belong here. Not just doesn't exist, it doesn't belong here, right? And letting our customers focus on what's unique for them. Yeah, so that's basically it. Thanks so much for your attention. What's next for us? Unless you have any questions, by the way, please go ahead. If you have any questions, I'll be happy to answer.
Question or comment. So if we are comparing this monolith and microservice architecture, so should we speak also about the Conway's law? That it's
yes.
And probably we should consider that most typically if you have one integrated development team, so probably the best way and the result will be one integrated monolith
yes.
system, and then so if you have different development teams, so probably then the best way would be each develop their microservice. And the problem is that when you start, if one small team tries to build a lot of microservices, then quite often it fails. And,
yes.
And so so the Conway's law is that your software architecture just reflects your organizational structure and your organizational application line. So what's your opinion?
Yes, you're 100% right. This is definitely an important concept. The Conway's law is essentially the idea that architecture is a social concept. First of all, means architecture is a certain agreement, right? How things are. It's not a prescribed thing, right? There's no book that says architecture needs to be like that. It's a social concept. It's about how people agree about it. And for people to agree about right architecture, you have to have a right organizational structure that reflects that. If you're going to put all people in one bucket, they will all agree on monolith or distributed monolith. If you decouple your organization in such a way that every team thinks about their particular business domain, or their particular capability that they're building, there are more chances that they will build something loosely coupled, because people don't like to depend on each other, right? And if people don't like to depend on each other, they will build systems that do not depend on each other. As simple as that, right? So that's, yeah, very good comment. Thanks for that.